Well, welcome to the next part of our unit on forces. This particular part is going to focus on a concept called freefall. It's actually got a somewhat confusing name because when you hear the word fall, you tend to think of things moving downward. But I'm going to show you in a second that in science, the definition of freefall does not depend on which way it's moving. So let me tell you what freefall is, and then you'll understand why the direction doesn't really matter. So in science, when we say free fall, that phrase means specifically anything for which gravity is the only force. Remember, you can always pause if you need to write a little bit more than the time I give you. So let's think about your situation now. So you're probably sitting in a chair, right? So that means there's a force on you from the chair or the floor or whatever it is you happen to be in contact with. So anything touching you is exerting a force on you. So for something to be in free fall means it can't be touching anything. It has to be basically in the air, and the air itself cannot be exerting a significant force on it. Now, the air actually exerts a force on everything that it touches, but for it to exert a pretty significant or a big force, something would have to be moving pretty fast, or it'd have to be pretty big, okay? So for a lot of things that are small or moving kind of slowly, we can just pretend they're in free fall and that gravity is the only force that is significant enough that we would count it, okay? So that means if I throw something upward, once it's out of my hand can no longer exert the force on it because it's not in contact. There's no magic force that just stays on it because it used to be in contact. So even if the ball is flying upward through the air, as long as it doesn't have a significant force from the air, we would consider that in free fall. If you throw, let's say, a golf ball flying through the air after it's been hit, now golf balls, even though they're small, they do move pretty fast. But if we could pretend that the air doesn't exert a significant force on it, we would consider that to be in free fall, okay? So we're not talking about being blown around by the wind or like a beach ball or something like that that definitely catches the air. We're talking about small things that are moving relatively slowly. Those would be considered in free fall. So what's special about free fall? A particular kind of motion results from free fall every time. And this is for all objects. They will accelerate downward. You can think of it like gravity. Gravity pulls down, causes things to change their motion. And there's a special number on the surface of the Earth, or near Earth's surface, when you get too far above the Earth, this number is a little bit smaller, but so what this means is 9.8 meters per second for every second that an object is in free fall. That's how the velocity changes. So if it's moving up, it will get slower. Every second it's in the air, it will get slower by 9.8 meters per second. If it's coming back down, it should be getting faster. 9.8 meters per second faster for every second that it's in the air, okay? And this is true regardless of the weight. So again, we're talking about situations where we can ignore the small effect of the air. It turns out all things fall the same way. If we had a race and dropped two things, if they were truly in free fall, they would always tie. Okay? So there's an equation for this. To find out the speed, and I'll have you do a little practice with this. To calculate the speed of an object in freefall, so here's the formula, and then I'll explain kind of how the formula works. Make sure you can see all this. We're actually writing an equation for velocity. Remember that velocity includes not only the speed, but it will show us the direction as well. So here's what we do. Now be careful how you write this. This is the speed, or technically the velocity. And this is the initial, or the starting, velocity. And this is how long it's in freefall. It's a time, T for time. Okay? So if we know the initial velocity, the velocity maybe with which I throw something up into the air, or maybe I throw it down through the air, and then I subtract this. It's a product of 9.8 times the amount of time. So in math class, they teach you an order of operations. You have to do this part first, the 9.8 times t. Okay? Get that number, then take the initial velocity and subtract that number that you get. Okay? That will give you the velocity after that much time has been spent in free fall. Okay? So I'll show you an example of how we'd use this just for a little bit of practice. Okay, well here's an example problem that you could do, and why don't you just write this one down. Pause for a minute and write this down. A small ball tossed upwards at 30 meters per second. That means you throw it up with your hand, and the speed that it has right after it leaves your hand it would be 30 meters per second. What velocity will it have after 2 seconds in the air? Okay, this is what that equation that I just showed you would be used for. Again, pause if you're not ready to move on here. So in our three-step system, we write the symbols first. V equals V initial, that's a subscript I, minus 9.8 times t. Then you write V equals and substitute in the values from the problem that you were given. So the initial velocity, this would be the velocity at the moment it starts being in free fall, after it's out of your hand. So that's 30 meters per second. Minus 9.8 times, and then the time is 2 seconds. I'm being a little bit sloppy with the units here. 9.8 actually has some units as well. 9.8 meters per second squared. I didn't write them in there. But as long as you put all your units in properly, your velocity units will come out in meters per second, as it should. Okay? So let's look at this. You got to do the order of operation. So 9.8 times 2. You have to do that first before you can do any subtraction. So I might recommend a fourth step here, just so that you don't mess up the math. Take a calculator, multiply 9.8 times 2. I do this number a lot, so I know it's 19.6. So what we have here is 30 meters per second minus 19.6. Okay? 19.6 is basically 2 seconds worth of gravity. Gravity will slow it down, 9.8, for every second it's in the air. So it's lost 19.6 meters per second of its initial velocity. So we do some subtraction and we'll get 10.4 meters per second. That's our velocity after 2 seconds. That's not so bad, right? You do have to watch out for the order of operations. Do that part right, but I think you're going to get the hang of it. I'm going to do one more to show you what happens if we start with something that's moving downward, and it takes a special thing to remember. Not hard, just something you got to remember. Okay, so a little twist on problem 1 for problem 2. Very important point I'm going to make about this. A ball is thrown downward at 30 meters per second. So maybe you're up on a high building or a tower, a cliff or something like that. You throw something down at 30 meters per second. Again, we're going to pretend it's in free fall, so small enough that the air doesn't have a significant effect on it. We're going to ask what its velocity will be after 2 seconds again. Okay? Here's what you need to know. All downward velocities are negative. In math class, you probably wondered, why are we ever worrying about negative numbers? Why did they teach us the negative number line? It's because we do things like this in science. So let me show you what we have to do here. The formula is still the same. V equals VI minus 9.8 times T. I'll put a little dot in there. You don't really need the dot. Just want to remind you that that's multiplication. Okay? But when we put in the initial velocity and it's downward, I have to put in negative 30. Put that in red so that it was emphasized. And then it's minus 9.8 times 2. Still have to do the multiplication first before you do any addition or subtraction. So I'll write out a third step here. Negative 30 meters per second minus, and it's the same number we had on the last one. Remember, 9.8 times 2 is still 19.6. Again, being a little sloppy with the units. I probably shouldn't have done that, but it's a lot to write. So look what we're doing here. Negative 30 minus 19.6. That's going to be a big negative number, isn't it? You can use a calculator if you want to. This comes out negative 49.6 meters per second. So let's look at what that means. That negative right there tells you it's downward. And doesn't this make sense? If you're up on a high tower and you throw something down, gravity will make it get faster as it falls, not slower. So you would expect a bigger number. That number there, 49.6, is the speed. The negative sign tells you that it's downward motion. Okay? So it's kind of neat here that we can figure out the direction of something just based on whether it's a positive number or a negative number. It's a trick we use a lot when we do problems like this in science. Okay? So on your worksheet, I'll give you one that starts with upward motion and eventually reaches its peak, comes back down, and you'll get a negative number for an answer, and then you know it's on its way back down. That's kind of how that works. Okay? All right. Hopefully 2 examples is enough. You always have the ability to ask your teacher for a little bit more help if you need it. Okay? We'll do it for now. On to your practice. Thanks for watching.